Alright, so welcome to the third part of the matrix series. And firstly, we will talk about pre-multiplying. So suppose I have two matrices, A and X, where A is a 2 by 2 matrix and X is a 2 by 1 matrix. When I multiply them, I'll get a matrix that is a 2 by 1 matrix. I'll call that matrix B. Alright, so AX is equal to B. And you must remember that X times A is not equal to B, right? Since matrix multiplication is not commutative. So let's focus on AX is equal to B. Now, if I want to make X, quote unquote, the subject of the formula, I will need to move A from the left-hand side of the equal sign. Now, this is where pre-multiplying comes in. So this is what we do. We pre-multiply by A inverse. And I'm just going to write the equation again. AX is equal to B. And pre-multiplying by A inverse means putting A inverse at the front of both the left-hand side of the equation and the right-hand side of the equation. And then we know that if we look at the left-hand side, A inverse times A will be the identity matrix. So I can get IX is equal to A inverse times B. And think of the identity matrix as 1. So 1 times X is the same as X. So then we have X is equal to A inverse B. That's how we make X, quote unquote, the subject of the formula. So now that we have an idea how to pre-multiply, let's look at how to solve simultaneous equations. Alright, so I have two equations, 4x plus 2y is equal to 20, and 7x minus 3y is equal to 9. The first step is to write the equations in the form ax plus by is equal to c. These two equations have the same format, so I don't have to change it. So then I label it equation 1 and equation 2. And now we set up the matrix form like this. We put the 4, 2, 7, and negative 3 in a 2 by 2 matrix. And then we put x, y as a 2 by 1 matrix. And then we equate it to the answers, which is 20 and 9. Right? We say now that this has the form AX is equal to B, where A is the 2 by 2 matrix, X is a 2 by 1 matrix, and B is a 2 by 1 matrix. Now remember before, when we wanted to make X the subject of the formula from AX is equal to B, we had to pre-multiply by the inverse of A, and so we get A inverse AX is equal to A inverse B, and then A inverse times A is IX, and then X is equal to A inverse B. Remember that X is XY is equal to A inverse. I've already calculated it to be 3 over 26, 1 over 13, 7 over 26, and negative 2 over 13 times B, which is 20 on 9. And when we multiply these two matrices, we get 4, 3. So we see that X is equal to 3 and Y is equal to 4. This is the matrix method for solving simultaneous equations.